Good afternoon, everybody. Welcome on our workshop. Thank you very much for joining our session. We want to take you really through few slides how to find ideal match and what you really should pay attention when you are deciding when you are choosing a disinfectant for your facility. I will run this workshop together with my colleagues, with Wolfgang Voigt and with Jedrzej. And at the end of the workshop, before Q&A session, we will show you QR code to the survey. We want to ask you to answer a few questions at the end, and we have a small gifts for you. So my colleague will be waiting in the back at the end of the session, and will give you those small gifts. So saying this, again, welcome on our workshop, and I will hand over to my colleague Jedrzej, who will tell you a bit how important it is to really have a good scientific understanding of chemistry and disinfectants to be really able to pass all latest efficacy standards.
Thank you, Jedrzej, and thank you for attending our workshop. So as you can see, I'm quite passionate when it comes to science, and the science we are trying to do is in a very relevant field. So we have a few challenges. We have witnessed excellent talks this couple of days, and one of the biggest challenges is hospital-acquired infection. As you can see from the figures, quite frightening, and some of these figures are quite a few years back, so I'm afraid the numbers might have gone up. But hospital-acquired infection in the UK alone is about 2.7 billion a year, and quite a lot of fatalities as it comes. The loss of man days is 80,000, which is significant. So economy-wise, it's really a bad thing. Just for comparison, United States are not behind. Actually, they're quite higher in that, but their population is high, so it makes sense. The bottom line is hospital-acquired infection is a really very dangerous thing to live with. So we have to find a way to reduce this impact on NHS and on our well-being. So one thing also that is not helping the situation is the AMR, the antimicrobial resistance, is not helping, and antibiotics are no longer capable of tackling that issue. Pharma companies have decided, okay, we are going to save some money. We don't have a pipeline full of new antibiotics coming out. And the reason being is that the microorganisms are so smart, they get resistant in a couple of years before they even get return on their investment. So the lack of new antibiotics is also not helping. And we decided, we are a microbial company, global leader in that. What can we do to really reduce the pressure on NHS as a general trend? And we have come up with a few ideas. So first of all is, let's boost the prevention. This is really the starting point. This is where we can make difference. Improve the disinfection, and that should significantly help reducing the burden of hospital-acquired infection. So what the solution is? Obviously, this is a big challenge, and the scale of the challenge determines the scale of reaction, or in our case, we call it pro-reaction. We are trying to actually be proactive, not waiting for things to happen. And in order to get new, affordable, eco-friendly, human-friendly biocides, we need to get to the bottom of what happens at very low micro level in terms of how biocide interacts with membranes, how it kills. We have little knowledge about this because the current offerings are subject of massive pressure from NGOs. You know, they are very proactive, they are very smart, very ingenious and creative. At the same time, regulatory get the noise and they start pushing biocidal companies producing such solutions, and we have to be smart as well. We have to find new solutions. So these challenges are big. But one example, we don't know much about kinetics of biocides. The usual EN standard testing, it takes a few minutes, you put it. If you're lucky, you get the 5-log reduction, off you go, you register the product, and you go to market, helping people. But you don't know the intrinsic mechanism, what happens at this level. And if we don't, it's very difficult to envisage what is the next generation of biocides. And we invest into this, really. And what we are trying to get, actually, with this knowledge is to foster our synthesis capabilities and come up with a new molecule. Because registering new molecule with ECHA nowadays is a big challenge, very expensive, and time-consuming. So we have to be certain when we go with the dossier that it will tick all the boxes. So what is the solution? As industry, we cannot afford very fundamental science. So what we do, we partner with academia and some science technology facility council organization in the UK. This is really generous. And we have recently applied for a big grant from BBSRC with Manchester University and ICIS at Rutherford Appleton Laboratory. So having access to these facilities give us access to the best in art equipment to probe the interactions at molecular level. And I'll give you an example just in a second. So having this, actually, we hope that as the grant develops, we'll be able to answer these major questions and we'll come up with new solutions. So please follow up on us on LinkedIn. We have scientific series starting up. And this is the last slide which I try to show you. And this is just a glimpse. This is something that will come out of press very soon. This is the level we are trying to get at. So how a molecule approaching a membrane, and we are looking at gram-negative microorganism membrane, outer and inner membrane, is interacting. So with this knowledge, we will be your best partner in the future. So I'll pass over back to my colleague Jedrzej, and hopefully we'll have a very productive workshop. Thank you.
Thank you so much, Jordan. So as you can see, science is extremely important to provide and deliver state-of-the-art active substances, state-of-the-art disinfectants, which will really allow at the end to provide ideal or as much ideal as it possible disinfectant. So what is really required, what you should really expect from ideal disinfectant? Obviously, proven efficacy based on the latest EN efficacy standards. Yesterday, I had this opportunity and honor to talk a bit about efficacy testing today, and I will try to give a bit deeper dive into this. But what else? We cannot forget about regulatory compliance. We cannot forget about good and broad material compatibility. That's not a secret for any of us, yeah? That's the huge cost for the healthcare system if you need to, or if healthcare system need to replace damaged equipment, which pretty often is extremely, extremely expensive. And last but not least, good cleaning properties. That was also outcome from other presentations, that you are really looking for a product which can clean and disinfect in the same time, which will also leave surface with a good aesthetics. So all those things should be really taken account, and that's why this science is so important. Okay, moving to the efficacy testing. A bit of follow-up on what I said yesterday. Please remember, phase 2, step 2, and phase 2, step 1, and phase 2, step 2 tests are mandatory to really be able to prove efficacy and to make antimicrobial or biocidal claim. Phase 1 tests are not enough. So suspension test according to phase 2, step 1, and whereas everywhere where phase 2, step 2 test is available, such tests should be also performed and obviously provide passing results. What are the differences? Based on the example of surface disinfection with mechanical action, so for instance surface wipe, against disinfection without mechanical action, so spray without wiping later on. Suspension tests pretty much the same in both cases. However, differences are coming from those phase 2, step 2 tests. So we can say carrier tests or tests which are simulating practical conditions. So in case of products with mechanical action, so wipes as an example, ready-to-use wipes as an example, you need to expect to prove bactericidal, yesticidal efficacy. You need to expect or require confirmation not only based on suspension, so 13727 or 13624, but on top of this 16615. This standard is mandatory from 2019. If I'm not mistaken, this standard is called four-field test. And according to the standard, you simply need to wipe surface, and that's how you are really confirming your efficacy. Whereas in case of product without mechanical action, you see that phase 2, step 2 test is different. And by the way, right now there is a medical version of the standard. In the past, there was 13697 industrial standard, which is not state-of-the-art standard anymore. So here, in case of such products without wiping, let's say, you also need to expect or require this 17387 standard right now. And similar situation in case of sporicidal efficacy. There are products, and I will talk about sporicidal on the next slide a bit more in the details. However, here you can also see that for products with mechanical action, you have, or we have right now, recently published standard. So not only suspension test 17126, but also this carrier test, practical test, we can say 17846. Whereas in case of products without mechanical action, you only need to rely on suspension test. And now moving to the differences. In the past, when we are talking about sporicidal efficacy, in the past, nothing was really available for a healthcare, and healthcare is obviously our focus. Nothing was available for a healthcare, so everybody were using EN 13704, which is industrial standard. Again, you shouldn't really allow to use such products anymore due to the simple reason. First of all, healthcare standard is right now available, 17126, and as you can see, there are quite massive differences between those two standards. So let's start with a required log reduction of microbes. 3 log reduction in the industrial standard, whereas in medical standard, 4 log reduction is required. That's a huge difference in terms of efficacy of the product. Different soiling, different conditions. So a medical one is really reflecting what you can expect in a healthcare setting. So under high organic load, that's not only protein load, but also blood. Last but not least, different type of mandatory species. As you can see in case of healthcare standard 17126, much broader set. And what is the difference? According to this standard, you are claiming separately efficacy against C. diff spores, and I'm really emphasizing spores, C. diff spores, not the vegetative form of C. diff, but C. diff spores, and separately efficacy against other bacterial spores. So here you can claim, product can claim efficacy, we can say, or let's say manufacturer of disinfectant can say that product is effective against C. diff spores. In such case, 4 log reduction against C. diff spores only is needed, or you can claim full sporicidal efficacy. In such case, 4 log reduction against all of mandatory. So Bacillus subtilis, cereus, C. diff is needed. And here few examples of somehow misleading claims or not really up-to-date claims. So here we have example, and please accept my apologies for the fact that this screenshot is not in English, but I really try to find examples across the Europe, yeah? But numbers, I think, are most important here. So here we have example of ready-to-use wipes, which are claiming efficacy against bacteria, yeasts, and mycobacteria under clean and dirty conditions. However, first of all, you can see that there is only suspension test. EN 13727 against bacteria, 13624 against yeast. 4-field test, 16615 is missing, which is mandatory from 2017, not from 2016. Okay, then claims based on DGHM, so old national German methodology. Again, it's making really difficult to compare this against other products because DGHM methodology is not harmonized to European standards. So same situation in case of virucidal efficacy. Here we have a claim built based on Robert Koch Institute guidance, which again is making very difficult to compare this against anything else because we have EN standard for virucidal efficacy with a tiered approach. So in this particular case, we have a claim against enveloped viruses. So here EN 14476 should be used with a proper mandatory organism. So honestly, based on this claim set, product is only properly tested against mycobacteria, to be very, very frank with you. Next example, quite a lot of organisms here, but as you can see, bactericidal only based on suspension test. Again, 4-field test, 16615 is missing. By the way, in case of 4-field test, 10-second contact time is not allowed. That's what we can see here in case of yeasts. 10-second contact time, which is not allowed because it's technically not possible to run this test within 10 seconds. Minimum contact time according to the standard is 1 minute. On top of this, for suspension test, you can see wrong species. It should be run based on Candida albicans as a mandatory test organism. And last but not least, Mycobacteria, again, wrong mandatory species. It should be Mycobacterium terra and Mycobacterium avium, not Mycobacterium bovis. Then, virucidal claim, a bit not precise really, because to be able to claim full virucidal efficacy, so against enveloped as well as all non-enveloped viruses, poliovirus according EN 14476 is mandatory organism. Next example, bactericidal efficacy according proper medical standard, that's great. What we are missing? We are missing one of the mandatory organisms. We are missing contact times. So how to judge? How to judge? I would also like to pay your attention that in some cases you will see claims, effective from 1 minute. What does it really mean? Effective against what? Efficacy should be claimed in particular contact time against particular mandatory organisms. Next example, bactericidal yesticide claims only based on phase 2, step 2. So here suspension test is missing, which is obviously also an issue. And next example, on the one hand, same product, different language versions of the marketing materials. And here on the left-hand side, in the English version, you can see that product is claimed to be active against, to have full efficacy spectrum within 1 minute contact time, whereas we can see in the detailed efficacy table that against Mycobacteria or against TB, 10-minute contact time or at least 5-minute contact time is needed. And here you have example how the proper claim set should look like. Here we have a product ready to use cleaner disinfectant wipes with bactericidal, yesticidal, and efficacy against enveloped viruses. So you can see suspension test, phase 2, step 2 carrier test, contact time, description of soiling, mandatory organisms, all you have available here. So such product with such claim set can be claimed as a bactericidal, yesticidal, and effective against enveloped viruses as a one-step cleaner disinfectant. And last but not least, regulatory aspect. As you know, disinfectants can be classified at least in 2 classes. So can be classified as a biocidal products. For healthcare, it will be PT2, product type 2. But they can be also classified as a medical devices, which is mandatory to disinfect other medical devices. Here, situation is even a bit more complex because we have a different class for invasive and non-invasive devices. However, pretty often, state-of-the-art, especially for non-invasive devices and all other surfaces, is to have so-called dual-use products. So medical device and biocidal product in the same time. And by the way, as a last remark, coming back to the efficacy, something what just came into my mind. In some cases, not only minimum contact time is described in the standard, but also maximum contact time depends on the application. So for instance, bactericidal efficacy or yesticidal efficacy for products in majority of cases will be ready-to-use products which are designed for high-touch areas disinfection, near patient disinfection, can have maximum contact time, not only minimum mandatory, but also maximum contact time. And in such cases, 5 minutes is maximum contact time. So let's imagine wipe product, which is claiming bactericidal, yesticidal efficacy, but within 15-minute contact time. This is also not state-of-the-art claim because it should be max 5 minutes. Okay, saying this, I will hand over to Wolfgang, who will take you through the material compatibility aspect and surface aesthetics. Thank you very much.
Yeah, thank you very much, ladies and gentlemen. Thanks, Jordan and Jedrzej, for preparing the scene. I think we all agree if you speak about a disinfectant, the most important factor is it has to work against the microbes. But still, something that works which has a very good spectrum of efficacy against bacteria, viruses, spores, and so on, which destroys your equipment very quickly, is not an ideal situation. So we also always need to have a look at the material compatibility to make sure that we are not getting a big benefit, but getting also a big disadvantage on the other side. Right, when you are going for material compatibility, when you choose a disinfectant, of course, you have to first of all assess which materials are to be disinfected. This can be metals, plastics, and elastomers. And depending on this type of material, of course, there are different types of corrosion, which are really important to look at. The problem with corrosion can be, on one hand, electrochemical corrosion, it can be a biological corrosion, or it can be a stress cracking corrosion, mainly for plastics. So depending on the type of material, you have to select the right test to really assess, do I have an issue with this disinfectant? Does it destroy or compromise my material? Do I have maybe only, in quotation marks, an aesthetic problem? Or is it something really that I have to frequently replace materials, which makes it very, very expensive? Or in a worst case scenario, do I really create an uneven surface by corrosion? And that is something where, of course, bacteria, biofilms have a good way to adhere to the surface and to be more resistant against the mode of action of disinfectants. So this is just, let's say, a scanning electron microscope picture or some pictures to see how such a rough surface can influence, let's say, the quality also of disinfectant. Bear in mind, all the EN carrier tests that Jedrzej talked about, they are done on a standardized smooth surface. So when your surface becomes corroded or is very uneven, that can have, of course, a totally different effect on the efficacy within 5 minutes, for example, in a given test. So you need to make sure, in an ideal world, that your surface is as intact as possible. Right, this is one example for pitting, so electrochemical corrosion. It occurs only at certain points. It can lead to a very deep penetration into the material, in spite of not showing a big amount of evidence on the surface. So this is actually very, very dangerous because you do not realize you really have a problem here. And especially stainless steel and aluminum, these are some of the materials which are pretty critical in that context. Right, this is just maybe a test that you also do for materials such as plexiglass, PMMA, polymethyl metal acrylate, which undergoes stress crack corrosion. You know, if you put it under mechanical stress, it corrodes much easily, and you see this cracking also on the surface, which, this is very extreme, usually it typically turns a kind of plastic window blind first, and let's say in the extreme case, of course, you can also destroy a device. Yeah, I wanted to show you a short video, and I hope I can do this. Or can you maybe start it from the, yeah, thank you. From the bottom, if you go there. And what we wanted to show you is a crack resistance test here with a specific alcohol-based disinfectant wipe, commercial product, and you have a plexiglass kind of bar that you have put in, and you put a load on that. And what happens if you disinfect with alcohol-based disinfectants? It will crack very quickly and very easily. On the other side, practically nothing is going to happen. We stopped the test after something like a week because there was just no effect on that. So that's very important if you have also PMMA under mechanical load. Let me just show you how this goes on if you see it from the top, and you see exactly what happens here. Again, on the left-hand side here you have the alcohol-based disinfectant. On the right-hand side you have, for example, here in this case, an optimized quad-based disinfectant wipe. And you see maybe here on the right-hand side of the left picture, you see this cracking already appear very quickly. And this is what finally leads to the mechanical failure. Right. Yeah, this is the important thing to give you an idea, how does the surface quality, the surface structure, morphology influence the formation of biofilms. The biofilms are these blue spots here, may have been made visible. And you see it here on this kind of femoral stem. Yeah, it's not really a corrosion here. It made a surface on purpose. But you see exactly, you get these wide areas of biofilms which are in the cavities. They are sitting there very firmly, and the smoother the surface becomes, the less of that you have formation. And you have these increased contact points which help the biofilm to stick to the surface. And on the other hand, you also have the shelter effect, because this is, of course, sitting in a cavity, and it's more difficult for the disinfectant to go there. Just as a quick overview, very generally, ceramic and glass, a lot of the typical used disinfectants in the industry, they are quite forgiving, yeah. But if you look, for example, at bleach, this has, of course, a limited compatibility with metals and also plastics and also elastomers. And because you simply have this corrosion issues. And with other products, you may have more or less a better compatibility. Sometimes maybe you have to compromise with the efficacy, but all of that is something you have to look at the specific device you are disinfecting. Have a look at these Carter wheels here. So you see here, if it looks like that, and this is the typical case when you disinfect with sodium hypochlorite. If you have to replace one of these Carter wheels, they may easily cost £5 a piece, and you have to replace four pieces every time. You do this, this can become a big burden financially if you have to do this. Right. But also cleaning is something, so the aesthetics, something important you have to look at. If you just compare, let's say, two different wipes here that you find on the market, one that we have developed and one that is also very popular on the market, you see here, if you make a defined scrub test on the surface and you try to remove these traces of dried blood, you can see that on the left-hand side with the optimized formulation, you have a much better cleaning efficacy. So this is a defined scrub test. You have a defined force, a defined amount of time. You go over the surface. Doesn't mean the other one will not work, but you need more force or you need more time to get the same effect. And also, if you disinfect the surface, what you don't want ideally is something that you have a very tacky surface. So you don't want this to be so gluey. And what we simply did is here to make a test, we disinfected surfaces, black surfaces. Very easy test. You sprinkle then some cosmetic clay on it, and you basically do this here. You get rid of the, let's say, superfluous cosmetic clay. You measure the weight difference, and the amount of material that sticks, that's the amount for the tackiness, or a measure for the tackiness. Let me speed up a little bit. Sorry, I realized we are a bit late here. Just to show you one product which we think that addresses a lot of these aspects in a very positive way. It's based on chlorine dioxide. The name is Nugen HLD, high-level disinfectant based on chlorine dioxide, and works within 5 minutes. Fully spirocidal, not only C. diff, but C. diff is, of course, very important. Very important is you don't need an activation. It's highly effective against bacterial spores. It simply degrades when it has done its job to water and to chloride after application, so nothing harmful in the typical sense as you define it. Very good efficacy with excellent material compatibilities. It's a medical device class 2A for the time being, can be stored at room temperature, and also in terms of CLP, you have no hazardous phrases on it. So what can this do? With a content of 200 ppm, you practically get the full spectrum, in this case here under clean conditions, in a maximum of 5 minutes. And also very important, this is very effective against biofilms. So unfortunately in Europe, we are working on a standardized method to really assess biofilms, but it's not yet there. The standardization committees work on that. So what happens is we made a test with the EPA method. This is actually, let's say, 1 or 2 levels even more demanding, and practically you are forming a very resistant biofilm. And the EPA criterion is that if you let this work for 5 minutes, you need to obtain a log 6 reduction, so a factor of 1 million. Very tough. But you see here with the blue bars starting from 100 ppm, you do the job and you do even a little bit better. If you do something with also something which is very often used for sporicidal properties, peracetic acid, the story is totally different. You are far away from this log reduction. Yeah, I just show you some examples. The material compatibility in general is very good of that product. And what can you see here? It was just these plates were immersed for 28 days in the solution. 28 days doesn't sound so long, yeah, or well, it shouldn't happen after 28 days. But think about 28 days contain 8,000 times 5 minutes that you disinfect with. 8,000 times a day, this would be 22 years. If you disinfect once a day. If you do it a bit more often, of course, let's say this effect may appear at a certain later point in time, but in general, the compatibility is also very good. Yeah, and this is just a test. I cannot go into detail here, but you will get the presentation. We have measured in the corrosion test also how much material do you lose due to corrosion effects. Right, and maybe this is the high-level disinfectant product, and if you want to go more in the direction of low-level disinfectants for a daily routine disinfection, you can also do this, for example, with a quaternary ammonium compound-based formulation. And just to give you an idea, and this was what Jedrzej showed you before, this is working within 1 minute, so time is key in this specific case. It works under medical dirty conditions, and it works against bacteria and yeasts, which are the mandatory strains. But of course, we all want to have also at least the enveloped viruses, and that also works very well after 1 minute. I had to speed up. Sorry a little bit for the speed here, but yeah, we are going to make a poll.
Thank you so much. So first question, please specify, and you will see answers on the next screen. Please tell us in which type of healthcare facility you are working in. Okay, can we move? What is your role in disinfection product selection? Great. Majority of you are infection preventionists, infection control. That's great. Which of the following criteria are the most important when you are selecting wipes, disinfecting wipes? Please select top 3. Some more time for those of you who cannot make a decision. Okay, let's move to the next one. I'm really curious. So full efficacy spectrum, material compatibility, and no pre-cleaning required. So basically three main pillars. I have to admit that I personally thought that wipe quality, non-woven quality, will be also important somehow here. Okay, next one, please. Again, multi-selection. In which of the specific situations or location it is most likely that you will require product wipe with a full efficacy spectrum? So sporicidal, fully virucidal, effective against mycobacteria, fungicidal, etc., etc., etc. Okay. So what the answers are? I would say pretty equal. So in pretty lot of cases, you are really looking after products with as broad efficacy as possible. I think this is also in line with sort of let's say philosophy, but also let's say current requirements. Okay, can we move to the next one because I'm conscious about time. What you are using currently in your facility? What type of wipes you are using in your facility currently? Okay, so in majority of cases, pre-impregnated, ready-to-use wipes. Thank you so much. Can we move to the next one? What is most important for you? Shorter contact time? For instance, if you are comparing against other product, yeah, when you are choosing wipes, if you can get a product which will have shorter contact time, how significant it will be for you. We are considering product with a full efficacy spectrum, obviously. And maybe in the meantime, I will tell you, because as I mentioned, Tom will be waiting in the back corner for you when you will be leaving to give you small gifts from us. Maybe I will explain what it is. Yes. So on the one hand, you have a brush, and you can brush your keyboard, and on the other hand, you have a cleaner to your touch screen. So I hope it will be useful for you. Okay, so very significant. As I thought, it's very significant to have such product. Okay, can we move to the next one? And thank you very much for being with us. What is the biggest limitation of your current surface verification method? So basically, what we are asking right now is, first of all, are you using any type of method to determine what is, let's say, quality of cleaning, quality of disinfection of hard surfaces? And if yes, what is the biggest limitation of this method right now? Okay, so pretty equal answers, yeah? Pretty equal answers. Okay, can we move to the next one, please? Do you feel your team can consistently identify whether a surface is free from pathogens after cleaning? So, okay, and the last one, really last one. Okay, so we are mostly assuming that everything is fine based on standard protocols. Thank you for this. And the last one, how valuable portable device which can detect 5 common hospital pathogens on the surface? Okay, I think we can move. I think that was all. Extremely valuable. Okay, great to hear.